Hello and welcome again to BitOxygen Academy. In last video we had discussed the GSM architecture in brief. Let's start this video for detailed study of GSM architecture. In last video we had seen three subsystems of GSM and their entities. Let's discuss all components of each subsystem in detail. First, radio subsystem. Radio subsystem consists of two subsystems, MS and BSS. MS has two entities, ME, that means mobile equipment or mobile terminal, and SIM, subscriber identity module. BSS has two entities, BSC and BTS. Let's see about the mobile equipment. We all are aware of this equipment. As we all know, it is a user device through which user can communicate with other subscriber. It can be distinguished by their power capacity and application. First is permanent or fixed terminal with the output power 20 volt. Second is portable terminal with output power 8 watt. And third is handheld devices with output power 2 watt. The handheld devices have experienced highest evolution. As the technology upgrades, the size, weight and power are decreased continuously. The life of battery between charging is also increasing. Let's see the function of mobile equipment. Voice and data transmission, speech encoding and decoding, frequency and time synchronization, monitoring of power and signal quality of the surrounding cells, radio channel management, and mobility management. Let's discuss about the SIM, Subscriber Identity Module. It contains SIM module, unique subscriber's ID, PIN, that is personal identification number, keys and algorithms for authentication and validation. It has CPU, ROM, RAM, and EPROM as well. It is identity of subscriber and not a physical mobile terminal. Without this identity, mobile terminal cannot work. It's useless from communication point of view. User can access services by inserting SIM into terminals. This means the only element that personalizes the terminal is the SIM card. SIM provides the function like authentication and validity of mobile station when accessing the network, user authentication, and it stores subscriber related information like subscriber's identification and cell location identity. Now let's see about the BSS, Base Station Subsystem. BSS connects the mobile station and the NSS. BSS consists of many BSC which are connected to a single MSC. Each BSC controls up to several hundred BTS. BSS manages radio transmission path between mobile station and MSC. You all must have seen this in around your area. It is known as a base station, and the rectangle device on it is known as a BTS. It can be of a round shape as well. BTS stands for Base Transceiver Station. BTS provides actual connection to mobile station. BTS is usually antennas used in each cell of network to provide coverage to that cell. It is placed in the middle of the cell. Its transmission power defines the size of a cell. The BTS contains the radio transmitter and the receiver that defines a cell and handles the radio link protocol with the mobile station. Each BTS has between 1 and 16 transceivers depending on the density of users in the cell. Let's see about the BSC, Base Station Controller. It is the connection between the BTS and the MSC. BSC manages radio resources of all the BTS that are connected to it. It handles handovers, radio channel setup, control of radio frequency, power levels of the BTS, and the frequency hopping. Mobile handoffs between the BTS under the control of the same BSC is handled by BSC and not by the MSC. It reduces the burden of MSC. What is handover? As you can see in the figure, when mobile user moves from one cell to another cell during call progress, it requires transferring the call to new base station that is known as a handover. It is always a good practice to use BTS and BSC from the same manufacturer. Let's discuss the second subsystem, that is NSS, Network and Switching Subsystem. It is a main part of GSM architecture. It acts like a normal switching node from and to other mobile subscriber or ISDN or PSTN user. Thus, it manages the GSM call in same network and also over external networks. It is also responsible for managing the accounting information of subscriber. The entities of NSS are MSC, HLR, VLR, and GMSC. Let's see the first entity, MSC. MSC is a high performance digital ISDN switch. This is the heart of a GSM architecture and NSS. It handles the traffic between BSCs and different networks like ISDN and PSTN. One MSC controls many BSC, which in turn handles many BTS. BSC are physically connected via a dedicated or leased line to MSC, or it can be connected via microwave link as well. MSC is connected with different database systems. MSC performs switching function for all MS located in the geographic area covered by its assigned BSS. It handles all signaling needed for connection setup, connection release, and handover of connections to other MSCs. Management of required logical radio link channel during call. Exchanges of signaling information with other system entities. All these functions are provided by MSC. Let's see the second entity, that is HLR, Home Location Register. HLR is a database of NSS that stores the information of subscriber which belongs to their home location. Each subscriber is assigned a unique IMSI and this number is used to identify each user uniquely. IMSI means International Mobile Subscribers Identity. HLR contains the detailed information of subscriber such as its current location and the allowed services. When subscriber moves from their home location to a new location, that is visiting location, at that time the VLR of that visiting location fetches the information from HLR and ensures about the services to which subscriber have access and which are restricted. Billing and accounting information is always generated by HLR. It is a distributed database. One PLMN may contain one or more HLR. Both HLR and VLR can be implemented in the same equipment, that is in MSC. Let's see the third entity, VLR, Visitor Location Register. It controls those mobile roaming in its area. It is also a database of NSS which temporarily stores identity of a subscriber in new area. VLR assigns TMSI number to a new subscriber who has moved from its home location to visiting location. Full form of TMSI is Temporary Mobile Subscriber Identity. It is always under supervision of MSC. VLR contains necessary information from subscribers HLR for providing all the services that is subscribed by a subscriber. When the subscriber enters in new location, VLR of that MSC will request information about new subscriber to its corresponding HLR. After getting enough information about user, subscriber is allowed to use the subscribed services. One VLR may be in charge of one or more location area. Let's see the last entity of NSS, that is GMSC, Gateway MSC. It works as a gateway for the calls originating from GSM and terminating to other networks and or calls originating from other networks and terminating to GSM. For example, GSM subscriber calls landline or PSTN subscriber or vice versa. Now let's discuss the third subsystem, that is OSS. The entities of OSS are AUC, EIR, and OMC. First, AUC, Authentication Center. This is a separate entity and physically included in HLR. It is responsible for authentication of a subscriber. This is a protected database and stores a copy of the secret key stored in each subscriber's SIM, like authentication and ciphering key. These keys change randomly with each call. This data helps to verify user's identity. Keys are never transmitted to mobile station on air. Only calculated response are sent. Protect against intruders in air interface. Let's see the second entity, that is EIR, Equipment Identity Register. This database stores IMEI for all registered mobile equipment and is unique to every mobile equipment. Only one EIR per PLMN. There are three types of IMEI: whitelist, blacklist, and greylist. Whitelist contains the IMEI which are assigned to a valid mobile equipment. Blacklist are those which are reported stolen. Greylist contains the IMEI having problems like faulty software, wrong make of equipments, etc. All stolen equipment and unauthorized terminals are found by this registry. When your mobile terminal is stolen and any call from this terminal will occur, EIR blocks the call and generates an alert if any. Let's see the third entity, that is OMC, Operation and Maintenance Center. OMC is a centralized maintenance and diagnostic center that controls and monitors the GSM system. It is connected with the different NSS and BSCs. It controls the traffic load of the BSS by allowing the network provider to operate, administer, and monitor the functioning of the BSS. It performs the tasks like maintaining network inventory, configuring network components, managing network faults, alarm handling, performance supervision and management, etc. As the network increases, the task of maintenance is transferred to respective BTS to decrease the maintenance cost of the system. So this was all about the GSM architecture and its entities. Hope you all have enjoyed the video and understood the concept. We will see how the call is set up using the GSM architecture in another video. Like and share this video to get the update of next video. Subscribe to our YouTube channel and click the bell button. You can also reach us on Instagram by following BitOxygen_Academy. Thank you. See you all in the next video. Till then, bye bye. Take care.